Alex is the Chief Technology Officer over at TransNexus, and he's going to give us an in-depth guide to Stir Shaken, a topic about which a lot of people here know a lot or not at all any. So I think this is going to be both educational and also entertaining. So Alec, take it away.
Yes. Well, I'm going to go through it as quickly as I can because we've got a lot to cover. And if you already know all about Stir Shaken, I'll apologize in advance. So let's get started. The first thing I want to talk about is what does Stir Shaken do? Because this is a common point of confusion I see. Stir Shaken provides a mechanism to identify the service provider that is originating the call. It also provides a mechanism for that service provider to attest to whether two things are true. First, if they know the subscriber that's placing that call. And second, if they know that that subscriber is using a calling number they're authorized to use. Stir Shaken does not, in and of itself, identify if a call is legal or illegal versus wanted or unwanted. It is an important input into other tools that identify that information. But Stir Shaken really is all about identifying who's originating that call and what they know about that call. So before we can talk about a call flow, we really need to look at what the ecosystem looks like. The ecosystem starts with the governance authority. The governance authority is a board. In the United States, it's 12 people from various service providers that represent the industry as a whole, and they set the policies. These policies are enforced by an entity called the policy administrator. The policy administrator in the United States is a company called iConnective, and in Canada, it's a company called Newstar. In other jurisdictions, there's going to be another GA, and there's going to be another policy administrator. There may be one for Europe or specific areas. I know France is standing up some infrastructure at this time as well. Now, the policy administrator is administering two different types of entities. The first is certificate authorities. Certificate authorities are, just like they are in the web world, they issue certificates. And then the other entity that they're administering is service providers. Service providers are the ones who are going to use those certificates and sign calls. And specifically, they're going to create something called a passport and sign that. And that's what we're going to look at here in just a moment. So let's look at the public key infrastructure that makes Shaken work and provides the trust in the Shaken ecosystem. So every service provider is going to run something called an SPKMS, the key management service. And what this is going to do a number of things. The first thing it's going to do is interface with the policy administrator in their jurisdiction in the country. And it's going to get something called an SPC token. This SPC token is a signed object that indicates that that service provider is authorized to be in the ecosystem. So only authorized service providers can get that SPC token. They're then going to create a key pair and put the private key in the secure key store, the SKS. They can then go create their certificate signing request using their key pair and send that request as well as with their SPC token to a certificate authority. And because that SPC token is signed by the PA, the certificate authority knows for certain that that service provider is authorized and is allowed to have a certificate. So that certificate authority can issue that certificate, and then the SPKMS puts that certificate into something called a certificate repository or an STICR, and this is what makes it publicly accessible to everybody else. So now we can talk about a call flow. Once all that happens, all of what we just discussed happens prior to a call and out of the processing of a call. And so when we get to a call, it starts with the subscriber, of course. They place a call. They send it to the originating service provider. And that originating service provider is going to send that call up to something called an authentication service. And that authentication service is going to do a couple things. First, it's going to decide the attestation level for that call. We're going to talk more about what the attestation levels are and what they mean in a moment. Then it's going to create a passport and sign that passport, and that passport's going to contain that attestation level. Now, in order to sign that passport, it needs the private key. So that authentication service is going to talk to that SKS in order to either get the private key or have the SKS actually do the signing, depending on how you do it. That call is then going to be sent downstream to a transit provider. And in the SIP signaling, in that SIP invite, there's going to be an identity header. And that identity header is going to contain that passport. And we'll take a look at what that looks like in a moment. Now that transit provider, they may send it immediately to the terminating service provider, or they may send it to another. It doesn't really matter. Every transit provider is just going to pass that identity header exactly as they receive it. They're not going to change anything. They're not going to do anything to it. Eventually, it's going to arrive at the terminating service provider. And that terminating service provider is going to use something called an STIVS, or a verification service, to verify that passport, to verify, does it match the call? Is it signed by someone I trust? Now, in order to do that, it's going to need to integrate with that STICR that we talked about before, which is what provides the certificate, so it can verify that that certificate is, issued by a certificate authority that's in the ecosystem and is trusted. Now, once it's made a determine on that verification status, that's where that CVT is going to be invoked, the call validation treatment function. This is going to decide what to do with that call. Maybe the verification was good, but you're going to mark it as spam, or maybe it was bad and you're going to block it. Again, Shaken is an input into the CVT function. It's not in and of itself the CVT function. Now, assuming that that call is not going to be blocked, then of course that call arrives at the subscriber. So that's a call flow, and that's really how Shaken works. So I mentioned we're going to talk about the attestation levels, so we'll go into those in a little more detail. There are 3 attestation levels. The first attestation level is A. This is full attestation, the highest attestation. When you sign a call, when you create that passport and you put A as the attestation level, you are certifying that 3 things are true. The first, that you are the service provider who is originating that call. You're putting that call on the network. Second, that you have a direct authenticated relationship with the end user or the subscriber. You know who is placing that call. The way I like to describe it is, if a 3-letter agency sent you a subpoena and said, who placed that call, you would immediately be able to answer it. That's the kind of bar you want to be looking at. And finally, that you know that the subscriber or end user that's placing that call has the right to use that telephone number. Now, it's that open. It doesn't mean that you assign them that number. It means you know they have the right to use that. Of course, if you assign them that number, you would know they have the right. But there are other ways you may know they have a right, and so they could use a number that you as a service provider did not assign them. So that's the highest level of attestation. The second highest level of attestation, attestation level B, has 2 requirements. And it's pretty easy. They're the same first 2 requirements from attestation level A. You still have to be the service provider that originated the call, and you still have to have an authenticated relationship with the end user, but you don't necessarily know that they have the right to use that calling number. And I want to highlight there's a key difference between not knowing and saying it's not true. If you sign it B, that doesn't mean that the subscriber doesn't have the right to use that number. It just means that the originating service provider doesn't know that they have a right. So that's why Shaken is kind of more of a, if there is an attestation level A, it means something. If it's not A, it has a little less meaning, because it doesn't mean it's bad. It just means you don't know it's good. So finally, the last attestation is attestation level C, and this is really the catch-all, the gateway attestation. There really aren't any requirements. The intent of this is really more to be used by someone who is outside of the Shaken ecosystem in a given country. Let's say a call originates, at a foreign country by a foreign provider, and then it enters into, whatever country we're referring to. Let's say the U.S. The service provider that receives that call in the U.S., well, they don't know who the subscriber is, right? They got it from another service provider, but they're the first one in the path to sign it, so they would sign that call at attestation level C. So now that we've talked about the attestation levels, let's look at a sample SIP invite. So you can see here I've got a SIP invite, and I've got an identity header in that SIP invite, and there is a passport in that. It's the big highlighted yellow blob. You can see it on both sides, I think. And we can decode that blob and get a lot more meaning out of it. So when we decode that, there are 3 portions of that, that passport. The first portion is what's called the header, and the header contains at least 4 parameters. It contains an ALG parameter, a PPT, a type parameter, and an X5U. These parameters are needed to verify the passport. They're not really all that interesting in of themselves. The only one I'll comment on is the X5U parameter. This is the link to that STICR that we talked about. It's what allows the verifying party to go get that certificate. Really, the meat of this is in the payload. The payload contains a number of parameters. The first one is the attestation level, and pretty obviously, there are 3 possibilities there, A, B, or C, correspond to the 3 attestation levels we just talked about. The next, there are 3 parameters. The DEST IAT, and a ridge parameter. So the dest and a ridge parameters are the called and calling numbers respectively, and the IAT is a timestamp. These three parameters really only exist to prevent a replay attack. When you create a passport, you put these parameters and they're going to line up with the SIP signaling. Someone can't take that passport out of that call and put it on another call and have it be valid, because it's only valid for a call with the same dest, a ridge, and approximate timestamp. And the definition of approximate is up to the verification service, how much leeway it wants to give. Typically in the ballpark of 15 seconds to 60 seconds is used, though. The final part is the signature, and the signature is over the header and payload combined, and it really just prevents tampering, just like any signature and any PKI infrastructure does. So now we can take a look at a certificate. Now the certificates used in Shaken are really, they're just X509 certificates, just like used in the web, but there's one extension that you're probably not familiar with that's outside of what's used in the web and exists just for Shaken. So, well, I've highlighted three parts here. The first one, we've got the issuer, and this is the CA who issued that certificate. So if you get a call, it's signed, and that certificate is issued by a CA, and you think something's up, you know what CA issued it. So there's some accountability there. The next is the subject, and that is the service provider that certificate was issued to. Now that format of that is a little bit more open, so that's kind of more just a textual name that describes it. So that's why the TN auth list extension was created. And this is specific to Shaken, and in that TN auth list extension, it's X509 v3 extension, is going to contain a service provider code with a 4-digit code in the US at least. That's going to be the OCN or SPID of the service provider, and this uniquely identifies a service provider in the Shaken ecosystem. So if you see some bad activity, you can go to the policy administrator and you can say, hey, I got a call, it was signed by this service provider, and identify them by their service provider code. And that's what that's for. So that's really a quick overview of the Stir Shaken core functionality. So now I want to talk about some extensions that are added on top of Stir Shaken. So the first one is out of band. Out of band Shaken is used to solve the problem of TDM, ISIP, SS7, anything non-SIP. When we looked at that call flow, you might remember we had that identity header in the SIP invite with a passport. Well, what if there is no SIP invite, right? What if it's not using SIP? Out of band looks to solve that problem, and it does that kind of as the name would imply by sending that passport out of band, outside of the signaling, over the internet. And then when that call is converted back to SIP, that passport gets re-put into the SIP invite, and ends up looking just like anything else. So that's a standard that's been around for a little over a year now. It's been in development for a lot longer than that. At this point in time, we're going to talk about regulations in a moment, but at this point in time, it has not yet been mandated by the FCC. So the next is something called delegate certificates. So when we talk about Shaken, we're really looking service provider to service provider, not end entity to end entity. It's really all about the service provider to service provider. Delegate certificates provides a mechanism to authenticate or to add some additional information in the enterprise or consumer to service provider, and then service provider to consumer, or again, enterprise. Specifically, the enterprise would create a RCD, rich call data passport, and sign that with a delegate certificate. And that can contain some additional information like their name and a link to their logo, their website, and all sorts of other information that then the originating service provider can put into the SIP signaling and put into that Shaken passport that they create, so then it is received by the terminating service provider and trusted. You can kind of think of it like a secure enhanced CNAM. The next, we've got div passports. So, we talked about the dest and orig number and how they have to line up with what is in the signaling and the passport. Well, what if you forward a call? You're going to change the dest parameter, the dialed number request URI, in the signaling. So that Shaken passport that was created is no longer valid. And this is where a div passport comes in. When you forward a call, you create a div passport. Div passports don't have attestation levels or anything like that, but they have the calling and called number as they both were and are now. So they link the new SIP signaling to the old Shaken passport, and they get added in. So you can get identity headers that are quite large because they can have a Shaken passport and potentially infinite div passports, one for every time it's forwarded. And the final thing I want to talk about is RPH passports. RPH are used for calls with RPH, resource priority header. This is things like emergency calls, 911 calls, PSAP callbacks, anything like that has a resource priority header. It provides a mechanism to secure that in a similar way to Shaken, but because there's not subscribers, RPH is used in place of Shaken for those types of calls. So last, I want to talk about the regulations in the United States, at least, as far as what service providers are required to do. So first, all service providers were required to implement STIR/SHAKEN when the Trace Act was passed at the end of 2019. And they had some extensions for when you had to implement that, depending on your provider, what type of provider you were and the number of other criteria. But at this point in time, there are only 2 extensions that remain. The first extension is facilities-based providers that have less than 100,000 subscribers have an extension that lasts until the end of June 2023. So, 8 more months? They don't have to implement SHAKEN. One common point of confusion we hear about that, though, is it actually applies on a per-call basis. So if you're a facilities-based provider and you have, some calls that use those facilities, but you also offer SIP signaling over the internet, to some businesses for trunking, those calls that use that internet trunking are not you don't get that extension. The SHAKEN deadline is already applied for those calls. And the only other remaining extension at this point is the TDM extension. So calls that use TDM are not currently required to have SHAKEN for the portions that use TDM. And that is something that the FCC is currently looking at. I believe the next meeting is on the 27th of October, and then the final kind of comments are due beginning of December, if I recall. So we're expecting the FCC is going to remove that extension. The Trace Act gave that extension and let the FCC decide when certain criteria were met with the standards, then that extension was going to go away. So they're going to be evaluating that over the next few months. Now, one other thing that service providers are required to do, service providers are required to file a robocall mitigation certification. And this is where you file a certification, it's publicly available to anybody who wants to look for it, that says what you've done. I've implemented SHAKEN, or I haven't implemented SHAKEN, and I'm not required to implement SHAKEN because I'm claiming this extension. You have to document all of that. And you may have seen in the news pretty recently, the FCC, I believe it was 12 providers got letters from the FCC. You have a certain number of days to correct your robocall mitigation certification, or you're not allowed to originate calls anymore, and no one else is allowed to accept calls from you. So the FCC can put out some pretty harsh punishments for people who have no robocall mitigation certification or a robocall mitigation certification that the FCC deems is insufficient. The final thing, I hear a lot of confusion from people about, whether or not they're a service provider. I'm just reselling some other, service providers' numbers, so this doesn't apply to me. And that is a common misconception, I think, because the definition of a voice service provider was dramatically changed at the end of 2019 when the Trace Act was passed. So I want to read the new definition, or at least a portion of it, from the federal law. Voice service means any service that is interconnected with the public switched telephone network and that furnishes voice communication to an end user using resources from the North American Numbering Plan. It goes on to say, or anything that's equivalent to that, and then it includes fax and all these other things. But that's really the definition there. Everything after that is not retracting any of that. So it's quite a broad definition, and really, I think a lot of people that didn't traditionally think of themselves as a true voice service provider are now a voice service provider, and are now, at least with regards to the Trace Act, considered a voice service provider and have to follow the FCC regulations. So last, I want to talk about the integration a little more specifically to FreeSwitch. So we talked about how that the call flow works at a little higher level. So if you have a FreeSwitch, for example, call would come in from the subscriber and enter into that FreeSwitch, at which point the FreeSwitch would invoke that STIAS. Typically, that's going to be done through a SIP interface, SIP invite sent to the AS. The AS is going to send back a SIP 302. Now, with FreeSwitch, we found that it's a little easier if the authentication service doesn't send back an identity header, but instead sends back an X identity header. Same value as you would, put in that identity header, but the FreeSwitch is a little more able to copy an X identity header out of a 302. Of course, then, you send that call downstream with that identity header with the same contents from the X identity, and you've got it. So that's a typical integration. There are other ways. Some STIASs work through a hairpin, some through HTTP, but that's probably the most common way that STIASs work. I do want to quickly mention, a little bit about Transnexus and what we do with regards to SHAKEN. We provide a number of solutions for telephone companies, SHAKEN being, one of those. We provide really a turnkey solution. So throughout this talk, I've talked about a lot of different things, from the AS, the VS, SPKMS, CVT, STICR. We provide all of those functions in a both cloud or on-premises deployment, depending on your network and what works for you. We provide both a SIP redirect, which is what I just talked about, and by far the most popular, as well as an HTTP interface that follows the ATIS 10082 specification. I will warn you that specification has been formally deprecated, and future work is being done in 3GPP. But that is the current in the US HTTP specification that is used. And we do provide the authentication service and all the related functions month to month and with the free trial. So if that's something anybody wants to learn more about or hear about, there's some contact information here. And then at the very end here, I've got a list of resources that you can go to. When the slides are provided after, this has got links to regulations and standards and just a whole bunch of useful information that hopefully helps. So with that, I guess I'd like to turn it over to questions. Two.
There. With the implementation of StirShaken, how many calls would you say percentage-wise on the network today are actually signed with attestation? And have you seen any carriers on the term end or any major carriers start to do call treatments at a larger scale, depending on attestation level?
Yes. So for your first question about what kind of calls and what those look like, it's interesting. We publish monthly stats about what our service provider customers have seen, and if you look at what we publish and you look at what some other companies publish, they're actually wildly different. But when you look into it a little bit, you'll understand why. It really depends on the type of service provider you're looking at. When you look at the big wireless carriers and you think, what are the majority of calls that they get from other big wireless carriers, and those calls are using direct interconnects between those two wireless carriers, so that Shaken Passport makes it through no problem. If you look at smaller providers, if you look at rural providers, you see a lot more transit providers in the middle between those wireless carriers and those small carriers, and a lot of those transit providers will use TDM. And so you will end up finding a lot less calls. So we've seen, depending on customers we look at, you could see customers that have 90+%, or service providers that have 90+% of their calls coming in signed, and then we see service providers that have virtually none, because the overwhelming majority of their calls come in through interconnects that are either directly TDM to them or TDM somewhere upstream. And then with regards to validation treatment, we have seen a dramatic increase in the number of calls that will be marked as spam or even potentially blocked based on Shaken verification results. I know of, we had a service provider that had some issue in their network and they stopped signing their calls for some reason, and they knew immediately because every single one of their calls was marked as spam. And so that was very quick to identify to them that something was going on in their network. And I think the way that it's done is not it's not black and white. What those CVT functions you're doing, you're looking to see, okay, this call coming in these trunks from these sets of numbers from these providers, they're typically signed. So when you see them unsigned, that's a big red flag, versus calls that are often unsigned, that's the status quo, so that isn't in and of itself enough to mark that as potentially spam.
Okay. Hi, I have a small question regarding that tiny extension on the X509 certificates, the TN auth list. In your presentation, you said that it typically contains some service provider code, right? But also on the RFCs, they say it can also hold like a number range, and a testing, like the certificate issued by the issuing company, attests that you own that number range. So I was curious whether, from what you've seen, if this gets actually checked, or it's mostly just kind of information that gets dropped, or
Yeah, so I'll answer your last question first because it's the easiest. Our STI VSs, I can really only comment on that, do validate that the certificate contains a TN auth list and that contains a valid SPC. I'd say valid looking. We don't have a list of every possible SPC. Now, as far as the TNs that can be in that TN auth list extension, so that is used for delegate certificates. So with a shaken certificate that's used by a shaken service provider, it will never contain a TN, and it will always contain a service provider code. With a delegate certificate, it's the opposite. So those are always going to contain a TN, or at least one TN range, could be multiple TNs, some combination of that, and they're not going to contain a service provider code. So that's kind of where you're seeing that in the RFC. The ATTEST documents kind of take within that RFC where each of those options are used. Okay, we might have time for one more. Any other questions or?
We've got a question from the online attendees.
Okay.
So, in a world where HTTPS certificates have been available for free for years, what justifies the cost of the certificates used for stir shaken?
Yeah, so really the cost for certificates is it's not so much about the certificates, it's about having a different PKI system, right? Just kind of a little bit of history. The original, in ATTEST, the thought was DigiCert and these other companies were going to come in and want to be CAs in the shaken ecosystem. None of them had even a small amount of interest in that. They all looked at the business case, looked at the number of possible companies you could sell a service provider to, size of service providers in a given country, and there's no business case. So none of them even considered it becoming a CA in the U.S. ecosystem, at least. And then other companies had to come in because we're not, the shaken ecosystem is not the same as the web, right? It's not the same PKI model, the list of certificate authorities, the requirements, the certificate policy statement that you have to comply with as a CA in the web world and in the shaken world are very different. So it's really more about that than it is about, kind of cost in a certificate. It's about recouping that audit cost of getting audited as a CA and all of that kind of stuff. So that's where it comes from. Any other questions? Okay, well, if anybody has any questions, I'll be around at lunch, and don't hesitate to come up and let me know. Thank you.